The topic of this video is about the flying chain fountain. Some people may think this simple experiment was conducted in the Newtonian era and was already well explained. But in fact, it was recently discovered by Steve Mott, and thus also known as the Mott effect. This phenomenon that caused more than 3 million views on YouTube is as follows. When the end of a chain is dropped from a pile contained at some height above the floor, gravity will set it in motion, and eventually the whole chain will have floated over the edge of the container. This seems perfectly reasonable. What is surprising though is the fact that the chain forms a rising, self-supporting arch that extends a significant height above its container. Careful analysis of the process was first carried out by Biggins and Warner. It was shown that this arch formation depends on the existence of an upward acting force that pushes the chain out of the container. They observed that the origin of this force is the key to understanding the phenomenon. It was explained by modeling the links of the chain as rigid segments that provided a kick against the underlying packing as they were lifted from it. This kick-off effect relies on the assumption that, due to the limited flexibility of the chain, it actually behaves as a sequence of rigid elements. With the force pulling upward, the rigid elements rotate abruptly around their centers of mass and provide the kick, because there is packing underneath them. However, simulations, experiments, as well as theoretical arguments used to explore the underlying mechanism for this phenomenon have shown that it depends subtly on the nature of the chain as well as on the container. Generally, it does not suffice to assume a model of the chain as a sequence of rigid elements that, due to angular moment conservation, kicks off from the container. Rather, the structure of the underlying system must be included. To understand what may cause the required upward force, we must analyze this structure along with the chain mechanics. We chose this topic because its relation to differential equations is clearer than other topics, and because none of us has ever seen this effect before.